All right, thank you very much, Mommy. Welcome to everyone. And as Mommy said, this is we realized that in the WadaGh team, we don't have like a lot of developers, and it becomes a bit challenging to discuss ideas on a technical level and even talk about executing those ideas. So we've put this together for you, and I want to make it clear that this is not everything you could ever know in blockchain and connecting to blockchain and whatnot. This is a program that is designed to get you up and running as soon as possible and to get you started. But the real success will come from consistent practice, and the real success will come from consistent practice and also exploring as much as you can on your end, because it is 2 hours a week and the rest is dependent on you to go and research and explore and follow the resources that we give you in here so that you can keep going. Two programming languages were proposed for this particular project, which is Python and JavaScript. One, because the barrier of entry is low and you get like a response as quickly as you write your code. And so that is the programming languages that we came up with. But we narrowed it down to Python because it's easy to learn and it's easy to adopt. And it's a very versatile language that allows you to do multiple things at the same time. You can build your app and analyze your data and connect to the blockchain and do all those things with this one programming language. Um, JavaScript could also do it, but Python has the power, especially when it comes to the data aspect and easy connection to systems and platforms like that. In the future, I'm not very good at Haskell, so I didn't touch it, but I know Cardano uses it a lot. In the future, we might switch to Haskell and also explore that depending on the success of the initial program. And so, without saying any much more, let's get started and talk about blockchain and Web3. Okay, so if you can see my screen, this short introductory presentation is dubbed Python to Web3, absolute beginners, right? So we are looking at exploring Web3 and blockchain with Python, which is the programming language. And the aim is to be able to set you up quickly with Python and get you to start learning the programming language as soon as possible so that you can um, learn the programming language, at least the basics. And once you understand the core concepts, you can go off and explore Python for yourself and ask a lot of questions. So, again, depending on the engagement and how this goes, we can set up like a forum or a chat on Telegram, and then we can have people ask their questions and try to solve their problems. Once we get all that set up, we could move on to writing a Python application and start experimenting with connecting to various blockchain technologies. There is Bitcoin, there's Ethereum. Ethereum is open source and it's a very popular one in the open source community. And then there's the Cardano blockchain itself. And fortunately, there's a Python library for exploring that as well. But before we delve into all that, you need to understand the core concepts of the programming language. And that is what I'm here to do. But first off, let's talk about blockchain, right? So we did all this last week, so I'm going to quickly run through it, and I'm hoping I can set you up with Python and have you write your first programming language before we exit this one, and then later on we might explore more. So a blockchain is a distributed digital ledger. I will explain, right? For secure, transparent, and tamper-proof transactions. So basically, there are some keywords here. It says it's distributed, right? For most of the systems that we interact with on a day-to-day basis, whether you're on an app or website, or even whether you are connecting to your bank online, even through text messages, most of them are centralized, right? Most of them are not distributed in the sense that you have to connect to a specific server or you have to connect to a specific repo and do your transactions there, right? Again, these are like databases and these are like data centers and things like that. But over here, note that it says that it's a digital ledger, right? And a ledger basically just keeps copies, right? So a blockchain basically is a distributed set of copies of transactions that people have undertaken. And it's a set of copies in the sense that everybody that is within that blockchain. So it's a set of copies that are linked to each other. It's a set of records that are linked to each other. And everybody on that blockchain has a copy of the records, right? And so um, instead of having a central place where everything is being kept, which can be insecure sometimes. We've had people break into Facebook's database and stolen user data. We've had the same thing happening to Amazon. Yahoo is the saddest of the bunch because it happens to them a lot, right? In the case of a blockchain, the data is hosted locally or the data is hosted by individuals and copies of the transactions are sent around. But even then, because everyone else has the copy, if somebody decides to tamper with someone's copy or a hacker tries to mess around with a copy on one person's server, if I may, or on one person's platform, what happens is that that copy is always communicating with the rest of the other copies on the blockchain, and and whoever whoever's copy is has been corrupted or has been tampered with, that copy quickly gets taken out, and a copy gets sent to him. And so we're talking about this tamper proof, nature of blockchain the last time, and I gave an example of how Singapore is exploring this for their banking system, so that it will be hard for hackers to hack into banks and steal from them. Some years back, about $32 million dollars was stolen in bank frauds, right, by hackers. And what they did was to hack the bank and then connect those banks to ATMs and then have various individuals go around those ATMs, cash out the money, keep a portion, and send the rest of the money over to the hackers wherever they were. And a total of about $32 million was stolen. Right. So with the blockchain, if this system was on a blockchain, it would mean that there would be a lot of redundant copies around, such that if the hacker messed up with one copy, it will compare it to the rest of the host of other copies on the blockchain. And if that copy doesn't seem to be in line with the rest of the ledgers that are on the platform, then that copy gets taken out and a new copy will be made to replace it. In which case, if a hacker wants to hack a blockchain, it means that you have to know all the ledgers, you have to know all the servers, and you have to hack all of them at the same time, which makes it more difficult and more challenging for hackers to do it. I mean, we've spoken about this, and it's almost impossible. I say almost impossible because we are seeing what AI is doing now. But even then, it will be very difficult for an AI to hack every single ledger. You have to provide those first, to know all of them and to hack all of them to the millisecond in order to be able to tamper with the records that are on that ledger, right? So this is the meaning of like all those keywords. And it's transparent in the sense that everybody on the chain can see every transaction that has taken place if they want to, right? And so you have a copy of it, and so it's not like a bank keeping your data or your information, or it's not like some tech company keeping your data or your information. The data is shared across all ledgers, and everybody has access to it. So, like I explained, it doesn't need intermediaries like a bank or governments or trusted third parties, right? Right now, all our records are entrusted to these institutions that we're just mentioning in this slide, right? Banks keep all our data, right? Governments and also the big tech companies that I mentioned. Like everybody on this platform is probably on Gmail, and that data is hosted on Google, right? Now, if there's a breach and someone decides to go into Google's database and still uses data. They have access to all the data all at once, right? Which is a scary thing if you are a big company or if you're a big business who does work with Google, right? Even if there's no breach and the system goes down, right? Then that means that for that period that the system is down, you can have access to everything. That imagine you have things on things like Google Drive, and you have documents that you need to retrieve. Once the system is down, it means that you can have access to those documents and you can use them. Same thing with the various social media platforms and the various platforms where people do serious business, like Amazon AWS and Microsoft Azure, right? So you are trusting a third party, intermediary, to keep your data safe, right? To keep your information safe. And in some cases, to keep your money and your business safe, right? And every time that third party company has a problem, then it means that you have a problem. But on blockchains and on emerging technologies, what happens is that the data that pertains to the individuals is stored on the individual's local platform, whether it's a phone or it's a laptop or it's even a server that you have to have some form of, storing your data, but it's stored by you and it's kept by you. And the only thing that goes out is the transaction. So it's like you can communicate with other people, but your data is not out there, right? A typical example is some of the systems that have come up nowadays for people to communicate. So um, one of them that I'm going to mention is not fully blockchain, but they make sure that you can store all your information should the central system go down, which is Discord. So Discord is a popular platform where you can spin up a server, right? And then store all your messages and all your information and all your interactions. But it still runs on a Web2 platform. It still runs on a non-blockchain platform. But Mastodon, which is a Twitter alternative, which was built when Elon Musk bought Twitter recently. Some people are on there. They are having some challenges. But the good thing about Mastodon is that your personal data, including your password and your email and everything, is kept locally. That data is definitely bundled up in your ID and sent onto people's timelines and the platform and stuff, but you can be sure that nobody can breach the system and steal a bulk of data or even one individual's data, because that data is being kept by that individual. So you own your data and you own all the information that pertains to you. And only the things that you say you decide to send out there is what goes out there. Unlike these systems we have where Facebook can snoop into your phone and see the activities you're undertaking so they can sell it to third party companies and sell you ads and stuff like that, right? So yeah, it doesn't depend on a trusted third party, and you host all your data yourself, which is very important in this day and age. Okay, so the term blockchain refers to the way in which, like you can see, transactions are stored in a series of blocks that are linked together in a chronological order, right? So basically, what he's saying is that all these transactions are stored in what we call blocks, and all these blocks are connected to each other and they're always communicating with each other, right? But these blocks are also stored in chronological order in the sense that it is stored in the order in which the transaction was made or based on the time in which the transaction was made. This diagram that we have here is a very simplified version, but actually what should be happening is that there's this should be in some sort of network or some sort of circle or something, as long as it creates a complete loop. But doing that will also create a very confusing image. So I used a very simple way to a very simple format to represent what a blockchain looks like. Right. So all these would be the ledgers, and all these blocks are connected to each other on a network, right? But the thing is that this stores all its transactions and all its information. There's a copy of that transaction here, but the original transaction that this made is only owned by this block and it's only stored on that block, if you get what I mean. And some examples of Some examples of blockchains include Bitcoin, which I've mentioned, and Ethereum, which is the middle one, and then the last one is the Cardano blockchain. All of these have become very secure highways on which transactions are carried out. The Bitcoin blockchain has been powering, if you like, the darknet or the deep web for a long time. I mean, granted, it is used by very, very unscrupulous people for very, very illegal transactions. But I mean, barring the moral and the legal aspect of it, it speaks to the success of this technology, because for a long, long, long time, the FBI, the CIA, the government, everybody wanted to snoop into it, especially on Silk Road, and they couldn't get access to it because these were highly secure platforms. And every time they tried hacking into it, well, they couldn't get to it because the information is decentralized and each information is stored on their own block, and it made it difficult for third parties to get into the system and disrupt it. Another layer of security that was added was that because these were transactions that were seen by everyone on the system, because it was that transparent, it was very, very hard for people to commit fraud. The only way people could commit fraud was if they met you in person, or they somehow found a way to get you off the platform to try and make payments in person. But what happened was that every time someone made a payment, that payment went into escrow, and the thing will have to be delivered, and you will have to um, indicate that you have received it before the money before the Bitcoin goes to the seller or the person who provided whatever service you wanted them to provide for you, right? And it has been very highly successful. The Ethereum blockchain is being used in several other places, and most of the Web3, which we'll talk about very soon, platforms that are being implemented today are on the Ethereum blockchain, um, which speaks to its flexibility and its ability to host all these new and emerging technologies that are coming up. Are there any questions at this point? Hello.
Hello? Yeah, yeah.
Yeah, are there any questions at this point?
No.
Okay, all right. So we're going to keep going. So I will send a video link after this introductory slide. There's a nice video that Cardano did on explaining what a blockchain is, which will take you in depth. I'll also provide a bunch of places to go and read about them and to go and explore more. And it can be a very fun and exciting thing to follow up. And I will find some other resources and add them up to it as we go along. Okay, so now let's talk about Web3. We spoke about blockchain, and we said blockchain is a network of ledgers, or of what we call blocks. And these blocks, they store transactions, right? But these blocks also store individual data that is unique to that block alone. And each block has an ID, and you can hack it, and it is super secure, and you can use it for all kinds of things, right? So blockchain is not very different from the internet we have now, except in the fact that people realize that other people owning your data is not such a good idea, because then it gives them some sort of advantage if they wanted to use the data for something. Typical example of this happening was the huge scandal that came up for those of us that follow news events with the US elections in 2016 with Donald Trump, right? The Cambridge Analytica scandal that came up, right? These were highly trained data analysts, and what they did was that they took data from Facebook, they bought data from Facebook and Google and several other companies that were known to provide like day-to-day services to the American populace, right? And they took that data, they did some analysis, they did some sentiment analysis, and based on the people's data, they couched campaigns and they designed the campaign to sort of trick people, if you like, or to sort of nudge people in the direction that they wanted them to go in. Same thing happened in the UK elections. Same thing happened in Trinidad and Tobago. The same company. And the same thing happened in the Ghana 2016 elections, which a lot of people don't know. There's a nice documentary called The Great Hack on Netflix, and it explores this company and what they did with the users' data. Now, imagine if this data was on a blockchain, right? Imagine if this data was on a platform like a blockchain. One, they wouldn't have access to that data. They could glean some insights, but that would mean going in there and individually following, say, if you had a social media platform that was on a blockchain, individually trying to find out, right, by writing out or by even manually, copying out text from people's posts and things like that. Because all this is not hosted on one big platform where you can get them in bulk, right? And they would have to manually do that, and they will have to get the manpower and the machines and things to crank that data for them, which would make it more difficult for them to do that and invade people's privacy that way, and even try to socially engineer people to vote for the parties that they they wanted those people to vote for, and to also hurt the democratic process. But because this wasn't on a blockchain and this was with a trusted third party, then that becomes the issue. But over here, Web3, which is started to be the future of web, basically is trying to take the entire web infrastructure or online infrastructure as we have it now and building it on top of a blockchain. So imagine this. Imagine if you signed on to a platform and your data didn't have to go into the database of whichever company owns that platform, but your data stays locally on your phone, but you can still interact with other people on the platform, right? Then that means that unless somebody has access to your phone and has access to, knows what they are looking for, because most of the data on the blockchain is encrypted anyway, unless people have the key to decrypt that, and they have access to your phone and they know what they're looking for, then it will be now impossible for anybody to get into your system and steal your data, right? And even if they do steal data, it is going to be one person's data that they stole without compromising the entire system, right? People have hacked into banks and stolen hundreds of thousands of bankers' data and use that to commit fraud online, identity theft, and things like that. Because all this data is hoarded and kept in one place, so these banks will have easy access to them. So these platforms will have easy access to them. So think of Web3 as taking the entire web infrastructure as it is now. We are in Web2 now, and putting it on a blockchain, right? So that even though you can interact with people across that platform, people, bad people, nefarious people, and even if it's not bad people, institutions, big institutions and big governments and big tech companies will not have data, information on individuals, and will not have access to individual data, if that makes sense, right? So the next evolution of web built on a blockchain architecture, that is what we refer to as Web3, right? And it is decentralized again, it is open, it is user centric, right? Internet that enables peer-to-peer interactions without the need of intermediaries, right? So I'm going to explain this a little bit. So if it says without the need of intermediaries, every platform that we have as WadaGh right now is not on a blockchain. It's a Web2 infrastructure, in the sense that every data that you send goes to an intermediate place. And from that intermediate place, the data is distributed to everyone else, right? So if I go to the Showcase platform right now, which is the one of my baby projects that I've worked on, if I go there right now, I can see everyone's email. I can see everyone's details, like the entire user detail, your email, your first name, and your last name. All that information is there, right there on the platform. Immediately I go there, I can see it. right? Being the person who developed it and being the person who set up the system, I have access to that intermediate or the intermediary platform, and I can look at all that. And if I wanted to take this information and do something with it, well, you have no control over that because you surrendered that information. And there's no way you're also going to be able to go there and change anything because you don't have access to that platform, right? You could change your user information, but if I copy the information I have on the platform now and I store it somewhere in a CSV file or in an Excel sheet, I have a snapshot of whatever you did now and I can store that, right? The same way, a hacker can jump on and have access to everyone's information. That is, if they get access to my platform, have access to everyone's information all at once, right? It is not open, and I've explained that. You cannot. You definitely cannot go in there, and even for some of the individuals like the team, the Oracle leads and the editor and other people that have given some level of admin access, I control all that. It is very centralized, right? I decide who has admin access or not. And if one day Richmond pisses me off and I'm like, I don't need him on Showcase, which is something that will never happen. But I'm saying if that happens, I can take him off. I don't know whether any of you heard of the Twitter files issue that came up a couple of like last month in February, where Elon Musk was releasing internal Twitter files, where because this system was being administered by human beings and individuals, these humans started that because you don't agree with their political opinions, they could go in there and ban you from Twitter. And even if they don't ban you outright, they could make it so that your posts don't get the reach that they're supposed to get or that they would naturally get by basically putting some constraints in place and making sure that people didn't see your post, right? Which is such an evil thing to do. Imagine if it was a more serious issue like a hospital system that is set up. You have a grudge with a doctor, and then they go into a system, and then they turn off your um whatever your or what's the name of this device? Your life support, right? Or they even turn off your this device that is used to enable people with heart problems, and then they just turn it off, right? All because all this is centralized and people can do this. And fun fact, the hackers that have actually hacked into hospital systems on Web2 platform and held the entire hospital to ransom, right? And threatened to shut down life support systems and pacemakers if the hospital didn't make a certain payment, right? Which is a big issue nowadays. And the banning is not only on Twitter; it has happened on Facebook. It has happened on other social media platforms, just because people have different political opinions, which hurts the free speech process, right? Which hurts all this. As for the bank issue, I've talked about it so many times. I'm not going to even mention it, right? So, unlike these systems that I've mentioned right now, Web3 is decentralized. It is open in the sense that anybody can spin up a server if you're connected to that particular blockchain and interact with other people on the server, right? It is very user centered in the sense that the user owns their data. Right? So if you look at the history of the internet, right, there's been Web 1 or 1.0, which was the only thing you could do was to read information that people have decided to put out there. You couldn't interact with it. You couldn't do anything. So if I have my own small server at home and I decide to build a website and I put some text and some cat photos on it, if you are interested, come and read it. But you can't interact with anyone, and you definitely can't add any data on, right? And then the internet bubble burst, and then we came to the age of the internet, which is Web 2, where we could do more complex things like add data on and retrieve data, right? So we retrieve most of the data through search, and we added data on by signing up and creating posts and submitting cat photos and putting posts on Instagram and doing all the and tweeting and doing all those things, right? And now, most people in the tech industry, with the advent of blockchain, are slowly shifting away from that system because we gave our data out, and these big companies and these governments and these banks and all these institutions have started using that data against us, have started using that data to basically engineer us socially and basically decide what we can and cannot see and what we can and cannot see, which is such a bad thing to do for any government, right? But unlike this is very user centered, and this combines the first parts of the Web 1 and parts of Web 2 in the sense that just like Web 1, you own all the data, right? But also, just like Web 2, you can interact with the entire chain and with the entire system, right? And have a peer-to-peer interactions. You can set up a store and sell to someone directly without some government snooping in, which is the thing that happened on Silk Road. Again, Silk Road is a very, very bad place, but I think it's such an exciting and such an interesting platform that if you have the chance, you should watch what do you call it? A documentary on. So just find a documentary on the dark web and Silk Road and try and understand how these people were so successful at what they did. So imagine bad people, drug lords, and mercenaries and assassins and things. It's crazy. They do exist. Using these platforms for these things. Imagine bad people using them and being so successful. Now imagine if you could take these platforms and use them for good stuff, right? And use them for something that has the potential to change society as a whole. Like our banking system here in Ghana, which is not strong, which again, people are broken into several times. These banks will not never come out and say this happened, but most banks face these threats on a day-to-day basis, and most of them have had to do some crazy patches and some stuff over the years, right? And even then, they still get broken into all the time. So Web3 seeks to take away all these weaknesses and make sure that the user owns their data, but then they can also interact with other individuals on the platform or on the network, right? Which is something that we should all be striving for because it gives us more freedom, more privacy, and more anonymity on the internet as we interact with people from day to day. So Web3 enables the development and deployment of dApps or decentralized applications on blockchain platforms, right? And in recent times, there's a lot of Web3 platforms that have risen. Um, sorry, 1 minute. There's a lot of Web3 platforms that have risen, you know, um, um, since the advent of blockchain, and people are exploring this. And these platforms and how people own their data.
Ezekiel, you are breaking. We can't hear you. Ezekiel, you are breaking.
Are there any questions at this point before I go on?
You were breaking. We didn't hear the last bit, please.
Oh, sorry. So I was saying that um, there were 3 platforms that have risen, especially in recent times, that people are exploring and people are, creating. I know there's an alternative to Netflix and there's an alternative to Twitter, which I've already mentioned, which is Mastodon, which is the one that became popular because Elon Musk bought Twitter and people were looking for other platforms to join. Other platforms to join. And sorry. And I there are several examples out there that you can go and look at. And I think it's important that we start exploring that again. Like you saw in the beginning slide for this Web3 part, it says that Web3 is the future of the internet. And people truly actually believe that. Jack Dorsey has started investing some. If you don't know Jack Dorsey, he's the former founder and CEO of Twitter. He left a couple of years ago, and he has started looking at the next tech infrastructure. The only sad and challenging thing that we talked about and the last time was how these big tech companies or these big investors will push for this in the beginning and make it look like it is designed to be better than the previous one and to benefit other people. But immediately they see what the benefits are, they start finding ways to monetize it and to break the system in order to make maximum profit, which is a huge challenge. But because of the way things are being set up now and because of the openness of these platforms now, it's possible for a truly, unambitious individual to set up their own blockchain and have other people have truly decentralized experience on these platforms. Note also that there are lots of platforms that will tell you they are decentralized, only to find out that they are still finding ways to siphon user data and keep all that data in one platform. Again, because data is the world's most important commodity today. It's more valuable than oil, if you can believe it. But it is. It is more valuable than oil. That's why Amazon doesn't care if it sells you $2 toothbrush because they are not selling toothbrush. Amazon sells data. They've got the biggest data infrastructure in the world to the point where even Microsoft, Google, Facebook, all those big tech companies do their backup on Amazon. CIA, FBI, NSA, the American government, other governments around the world also do their data backup on Amazon. That is how big Amazon is. That is why they don't really care about selling things cheap on the Amazon platform. So if you ever hear of Amazon and you think, oh, cheap stuff, that is not the point. They are selling data. They've got the biggest data platform, which is Amazon AWS, and that is where a bulk of their money comes from. And these big tech companies are getting into this Web3 game. And it's important that individuals like us and small groups like us can also get into the game. And it doesn't take much to get into Web3. I mean, you do need some technical knowledge, but most of the infrastructure has already been designed and open sourced, right? It's important that we know how to connect these blockchains and to conduct transactions and to build our own platforms around them, right? And it's especially important for those of us in this part of the world where we're still exploring some of these infrastructure and some of these systems. Imagine if a country or a government embraces this in a truly altruistic fashion, which I know sounds naive coming from me and looking at what we are facing in this part of the world. But imagine if a government could embrace this and implement it, then it will mean that people will truly own their data. And it will also mean that we can design and develop a whole new infrastructure for interacting and for carrying out transactions and for doing all these things, which is something we are going to explore in subsequent sessions. So Web3 is designed to be secure, to be transparent and autonomous than traditional web applications. They offer a range of features such as smart contracts, which is something that I know Cardano is exploring a lot, which is something that I also know is on uh, Ethereum, right? And then there's decentralized finance or DeFi, which again, I know that some people on this platform are really into and they're really like looking into and studying. And I've also mentioned that the government of Singapore is also looking into this to apply some, you know, level of blockchain technology to prevent people from snooping in on user data and stealing bankers' information. And then there's non-fungible tokens, which again, I know that's what I is closely associated with because I'm working currently on the Afrix NFT platform. And NFTs are non-fungible tokens. I say something is non-fungible is basically you can't tamper with it, right? So you generate a token that is related to a specific item and nobody can change that token and nobody can play around with it because that token belongs to you and you alone, right? And then there's decentralized storage, which is the newest in the technologies that are available for Web3. I've seen some promising ones, So it serves as a sort of a database, but all it does is keep data IDs. But all these data is still kept on individual ledgers and on individual, basis. So it's still decentralized, but the storage keeps, keys, data keys and data IDs, so that people can fetch data from there, but only if the user or the owner of that data allows that people can fetch that data. And having decentralized storage is very, very important in the sense that it also makes it easier and faster for people to interact with a blockchain. Currently, the way blockchain is, it is not as fast as Web 2, but if you have a decentralized storage, then that could be possible. Now, I'm going to talk about another paradigm or another dimension of decentralized storage. Imagine this, that you don't have one central, finite storage, but that you could use the storage or a portion of the storage of everybody on the chain as part of your database or as part of where you store information. That would be a game changer. I saw this concept being explored in the movie Startup. It's a TV series. If you like tech a lot, you will enjoy watching it. Talks about how a startup, as like how people start startups in Silicon Valley and the challenges they go through and some of the stuff. And one of the technical things that came up in that series was they built an app, but they didn't have money for uh, servers and databases and storage. And they needed to go and demonstrate this app. And so what they did was they co-opted just a little of the storage of all the users that were on the platform, which was in the millions. So imagine if everybody on the platform has at least nowadays, at least you have about 128 gigs. Imagine if subtly that 20 million people on your platform, and you can take just a gigabyte or 500 megabytes out of the platform. If you take a gigabyte, that's 20 million gigs, which translates to a huge storage space. If you take a 500 megabytes, that translates to 10 million gigabytes, which is also such a huge storage space, right? Imagine if that was the case and you could store a bit of your data on all these platforms, right? And somehow pull that data where you need people to see them, because that's how it was demonstrated in the movie, right? And somehow pull that data when you wanted people to see them, right? And you could just hide it under the hood. Again, this is something that is not new, in the sense that Facebook will fetch some amount of data, store it on your phone, and make you feel like the data you're browsing is really, really fast, right? So that if you run out of data, you can still open Facebook, because right before you run out of data, they cached some of the data and stored it. So you can open Facebook and quickly see the first few posts before you even realize that you've run out of data, right? But instead of caching the data, you could actually use this as a semi-permanent storage and move the data around. Just store data ID keys and have this data fetch and presented in an interface every time you want to fetch it, right? So these are all the possible technologies that are available and that are possible with Web3, and people are still exploring more. And as they come up, we'll point them out. Now we're going to do blockchain as a session on its own and Web3 as a session on its own. This is to whet your appetite and to just introduce you like a broad introduction to the whole system, and then later on we'll get in depth with all of them. All right. Are there any questions before I do this very exciting part? Hello?
I don't have any question. The only thing is the links that you are telling us refer to. Can you put it in the chat
Okay, all right.
so that
So
we don't forget?
I'm going to, because I'm sharing my screen here, I'm going to open it on another on my phone and then send all of them to you.
Okay.
Okay. All right. So oh, this is going to rain. Okay, mommy, is it okay if I collect all these resources and put them on the Water Ghana platform?
Okay, so all you can do is you can give them to me, and then yeah, I will share it.
Okay, I'll do that.
Okay, thank you. So you can go on.
Okay, all right. So, and now we've had a brief introduction to blockchain. We've had a brief introduction to Web3, which is basically the web built on blockchain. Now we're going to talk about this very exciting part. Everything is a program. Everything. Like almost everything that we interact with today, all the digital systems, all the things, your PC or your phone that you're on now, that you are interacting with, the interfaces that you are touching, the tweets that you are sending, the WhatsApp messages that you are sending, the emails, the text messages, everything is a program, right? And believe it or not, everything is a bunch of several lines of code dictating how these systems should work. And somehow these lines of code have been put together into beautiful interfaces that you can click and swipe and tap and slide and scroll and do all those things in order to receive a certain response, right? Every time you click on an app, there are probably several processes that run in the background, either on a server or on on your phone, even locally, in some command, whatever hidden in the background, right? In order for that system to respond the way it needs to respond, right? So I'm going to quit out of this because I'm going to talk about a bunch of things, and then I'm going to come back to the last part of this, and then we'll set up a Python environment just to demonstrate what I mean by everything is a program, right? So give me just a minute. I will set up and then I'll get.
Are we waiting for Ezekiel? Is he coming?
Yes, mommy. So I just want to set something up and then we can run through a demo as to illustrate why everything is a program.
Okay.
Okay, I'm back. All right.
Welcome. We are
Thank you
waiting.
very much. Sorry. So I said everything is a program, right? Now think about it. Everything you click on the phone, even when you boot up your phone, right? Even when you start your phone, it's a program. It's a program that runs and show you a series of like nice graphics. But you could also, if you know what you're doing, snoop behind and see exactly what is going on, right? If you open VLC Media Player to watch a movie, every click, every play, every pause, everything you are doing runs a program in the background, which is just a series of code that somebody wrote and said, if the person double clicks this and they set VLC as their default media player, it should open VLC and play that, right? So I'm going to show you something side by side to demonstrate what I'm talking about, right? You can see the command interface that I've opened here on the right side, and then you can see the web browser that is here on the left side, right? Now, this right here is the page for is the local server on which I test the showcase before I put it on the server if we add a feature, right? Now, if I press enter to go to the home page for showcase, immediately you should see a bunch of code run in the background here on my command interface. And every time I interact with something, you should see another set of lines of code just appear here because I wrote the program and I wrote the program in a bunch of folders and a bunch of files which are connected to each other, right? So if I hit that, you can see that something got fetched, right? Actually, let me reduce this to mobile interface so it looks good. Yeah, you could see that something got fetched, and all of a sudden, all these lines of code is appearing in my command interface, right? If I hit browse proposals, a few set of lines should open up. If I go back and I go to the menu and I go to login, say, I put in my login information, something should happen again, right? And believe it or not, it doesn't matter which platform you are interacting with, right? This is running somewhere in the background on a server, just like this. Every time, if I click to go view this particular profile, this is what I get, and this is what I see running in the background, right? If I click on any other thing that is supposed to take me elsewhere, again, I'm going to have a bunch of lines of code running in the background. And this is what is happening probably several hundred times every time you interact with a platform, a digital platform, or an interface. And believe it or not, this is not limited to your PC or your phone, right? All those fancy gadgets that you have that have interfaces, your smart TV, your microwave, right? Your new smart fridge, all has this exact same thing happening. That is what I mean by everything is a program. And everything that programmers write or everything that programmers work on, they look exactly like this, right? So somebody has sat down and they've written a bunch of logic and they've written a bunch of parameters and definitions and decided how things should behave. If we go back to the showcase platform, I wrote a bit of code and I said that if the person clicks their name, let this pop up. And I wrote another one that said that if the person clicks log out, right, take them back to the home page, pop something at the bottom and say you've logged out now, right? And all these things, you can see that a bunch of things popped up again. Said log out 302 and then give me a 200, whatever. That is something for another time. But you can see that every time I interact with something here, some code runs in the background. Some response get generated in the background. And all these are just a bunch of lines of code that are put together. All the sophisticated interfaces, all the nice platforms, that thing you go to the bank to use. In Cowbank, they have this teller systems. That's it's not even a teller system, it's just a dispensary system for taking tickets in order to go and see a teller. If you go to an ATM, the screen you see on an ATM is actually running on either Windows XP or Windows Vista. And every time you click withdrawal of cash or whatnot, there's a specific app or there's a specific program that has been written to run in the background like this. And it really doesn't matter. I wish I was on a Linux platform because it's more beautiful on a Linux platform. Again, to give you another demonstration, I can interact with my entire PC without clicking my file manager. So if I go here, if I quit out of this, and I want to see all the files here, and I type ls or dir for directory, and I can see all my files here, right? I can change directory by typing cd, go into say proposals, and it will take me there. If I type ls, it should show me all the files in there. I can delete, I can write, I can do everything to a file here without ever opening my my file explorer. And I can do all these things because the file explorer, it's a program that will run these same commands that I'm typing in here and do that. And this is a very nice short demo that I often give my classes to demonstrate that everything is a program. If I was on my Linux machine, I could even open something through the terminal and run that program like a VLC media player, open through the terminal, run the program on the side, and show you live what happens every time I hit the play, pause, or whichever button, which is something that we might also explore once we start doing the real programming stuff. So just to demonstrate, everything is a program. Everything you're interacting with today is some form of simple functions that have been put together in a way that makes it sophisticated and to perform all those things that it performs. If I had a platform that was showing live video, you would see that every second or every millisecond or every 5 milliseconds, there are like there's code that is loading and basically taking the image, images and basically stitching them together and making them continuous to appear as though there is movement or there is motion. But it's just a bunch of images that is being shown to you really, really fast. And it's behaving as if I'm moving my arm or I'm moving my face or I'm moving my head. This program that you are interacting with, Google Meet, it's a program that is running in the background. There's, I don't know if I can show you the debug console and if anything will show in there, but this is the code. This is the code for it right here. All of this is what it's showing you, this nice interface. And when I hover over it, you can see that it's selecting different portions of the frame and showing you all kinds of things. But this is the code controlling the entire interface, right? Which is, again, amazing to me, like how these things work. I really, really love exploring these things. I could go to, say, the network and show you a bunch of other things that is running in the background and what is being fetched. And this is the meeting ID. This is the first one. And you can see every time I interact, I'm talking and it's fetching the audio and it's sending it to you. So code keeps loading in the background because this audio is also being packaged in what we call packets and are being sent in a continuous fashion so that you can hear me. Else it will break and then you hear the next few bits later than I've said it. But these are being packaged live and these are being sent to you live. And as you can see over here, every now and then it will load a little bit, and every now and then it will load a little bit, and every now and then it will load a little bit, which makes it truly amazing, right? So again, like I'm saying, everything is a program. Every single thing you interact with today is a program that was designed by someone, right? And that is what we are going to be doing. We are going to be programming. We are not going to get stuck with something that someone has designed anymore or something that someone has built anymore. Granted, we'll get stuck with a couple of them, but after this introductory class, if you take it along and you explore it a little bit further, it will mean that if you have a service and you can't get it, you can't get a certain specific feature on that service and you get angry, you can go and build your own service, right? If you have a music player that you want to remember all your playlist and do all that, I mean, I know they do it, but if you have a certain something that someone has not thought of, you could one day get up and just build your own service, right? One of the services that I'm very interested in is data management services, where we take data from like big data from like labs and companies and things and try and make it easier for them to understand and be able to print reports and do all those things on. That is one of my favorite things to do nowadays. And if you want, you could build that on your own, because now you know how to program and you know how to make your computer do things. And that is basically what we are going to be doing. So every click, think about it. Every click, even when you're shutting down your machine, you send a command to the computer, some code runs in the background, it goes through the checks, but it, all in front of you, just show you a nice graphic while it's doing that. So there'll be a loading button or something while it's doing that. And once those checks have been gone through, it will just connect to the hardware and just switch off your machine. That is basically what is happening with these things, right? So that is basically that with everything is a program. I hope it's interesting. Do you have any questions at this point? Because right from here, we are going to be installing Python. We are going to be installing what we call an IDE. We'll talk about it. And we are going to write our first Python code. Are there any questions? Okay. So if there are no questions, then we'll go ahead then. So if you can see my screen, so what do you need? What do you need in order to be able to write a program? Well, first off, you need something to do it on. So basically a PC, right? Today's PC or modern PCs have basically everything you need to write your first program, right? But in order for you to write a program that both you and the machine can understand, you need to learn a programming language. So you need a PC, you need a programming language, or you need to install an interpreter, and you need some other stuff. So you need your PC, you need a code editor, which is where you write your code, right? If you like, you could write your code in Microsoft Word, but Word is designed for you to create documents, human readable documents, and to make them beautiful and to do all those things, right? And so it's not ideal for writing code because a code can be hundreds of thousands of lines, and you need to find a quick way to process that code without crashing your machine. And so you need something to handle that. And what you need to handle that would be a code editor, right? In some cases, you need a browser. If you're doing JavaScript, you can basically write all your code in the browser, even without installing JavaScript. In fact, you don't need to install JavaScript. All you need to install is a very good code editor, and it will come with JavaScript bundled into it, right? So you need a PC, you need a code editor, you need a browser, and you need the programming language itself, the interpreter itself, right? So from here on out, some people installed Python last week. We will install Python. We will install a code editor and the necessary extensions, and then we will go ahead and write our first Python code. It's going to be a very simple code that we're going to write. And then in subsequent classes, we'll explore blockchain in detail. We'll explore Web3, blockchain and Web3 in detail. And then we'll start exploring some programming concepts with Python. And then we'll start playing around with mini projects and doing all those things, which is very fun. And then in phase 2 of this program, that is when we will really dive into and explore building useful applications and connecting to blockchain and doing all those things. And once that plan is set up, we will have a discussion. Once that plan is set up, we'll put it out there, and everybody who is really serious and wants to join can do this. But at the end of this first part, or the first part of this program, you should be able to at least have some knowledge in Python and be able to explore and be able to write bits and pieces of programs that you yourself want to use to solve your personal problems. And you should technically be able to connect to a blockchain and interact with it. But if you want to build an interface to support it and do like I did with Showcase and all those things, then you need to join the subsequent sessions and see how it goes. So without much ado, let's install Python for those of us who haven't installed Python yet, right? In order to install Python, you need to go to python.org on whichever PC you're on, be it Mac or Windows. Just go to python.org, and then you can go to downloads.
Ezekiel,
Mommy.
do we do it now? We follow you and do it later. Do we do it as you are doing? We are going.
Yeah, I think you should do it as I'm going. But mommy, I think you already have Python installed on your PC. So please, for those of us who haven't installed it, just follow me and let's go along, right? So you can go to python.org and click on downloads. And then if you're on Windows, in fact, it should detect the platform you're on. And all you have to do is to click this download Python button right here. I already have Python installed, but I'm going to go through with you so that you see how it works, right? So hit the download Python. I mean, I'm assuming everybody has downloaded the program before, right?
Yes.
Okay.
Assuming.
So let me know when your download is complete, and then we will continue. It's a very small program too. It's about 24 megabytes, smaller than certain applications. Please, once you are done downloading, just leave a comment in the chat or just raise your hand in the chat so I know you are done downloading so we can go ahead. I think Ebenezer, you are the only person here who hasn't installed Python yet. Okay, awesome. So if everybody has Python, then we can go ahead and install a code editor. And one of the best right now is Visual Studio Code, right? I mean, it's not optimum for Python, but you can optimize it for Python. That's what makes it wonderful. So if you go to code.visualstudio.com, you should come to the page that I have on my screen. And again, I think Mommy already has it. Edufua has it. Richmond, you have Visual Studio Code. And so Ebenezer, again, this falls on you. If you already have it, then we can move ahead and start, doing some fun stuff. Ebenezer, do you have that? Okay, awesome. So install Visual Studio Code and let us know when you're done. Okay, so while he's installing Visual Studio Code, let's talk about programming and programming languages. So again, programming is basically giving your PC or your machine a set of instructions to execute, right? And programming in modern day um, can be paired with a nice user interface to make it easy for people to interact and talk to their machine. Every time again you click an app or you click a web link or you click anything on your on your on your laptop or your phone, you are giving the phone a set of instructions, right? You're giving the laptop a set of instructions. Like right now that he hits the download button, basically what he said to the laptop is go to this address. Now go to the wherever the package is stored on Microsoft server and download that package for me so that I can install it, right? So it will do that. When he double taps the the setup and it starts running, he's giving the machine another set of instructions. He's saying that, hey, now take this package and install it together with a code editor so that every time I click on the icon, it displays the code editor. And when he clicks on the icon, another instruction is sent to the machine that says, I want you to open this application right now and show it to me now, not tomorrow, right now. And the machine will do that, right? So every time he's interacting and at every level of that interaction, he's basically giving instructions to the machine and the machine is doing that. But these instructions are predefined. They are predefined by whoever built the program, right? So if you go to Facebook and you hit the post, add post or new post or whatever, and you do that and you upload a picture, all this is predefined. Mark Zuckerberg and his team have predefined that people would like to post photos here, but when they upload the photo, they would like to add text to it. So let me provide this area where they can add text. It's the same thing I've done again with Showcase. Sorry, I just typed Showcase. Jesus. And guys, Showcase is on the showcase.wada.org subdomain now. So if you type showcase.wada.org, it should take you to Showcase directly. right? So yeah, so all this have been predefined in the sense that if I go to publish, right, it brings me here. It's predefined that when he clicks this button, take him here. And I've also predefined that if I click articles, then take me to an interface where I can publish articles, right? Give me a place where I can put the title. Give me an options place so I can select a category. Allow me to upload one header photo and allow me to um, start typing my post so that I can post this to the platform, right? I've also defined that if this person is not an editor or a lead and they create a post, don't show it directly because the post might have errors and mistakes and grammatical errors and things in that. Put it in the database, show everything to the editor, and then when the editor edits it and he thinks it's okay and he hits publish, then it can go live, right? So if I go to articles, you can see that for leads and editors, if you go to articles, I can click the article and go directly to the article like this. Or I can hit that small pencil icon there in the corner, in which case it will take me to a place where I can go and look at the posts, I can edit it, and once I am satisfied, I can check this published icon here, and I can hit that, and then this is going to go live. So if you're an editor, you should see all the posts that have been submitted. You should be able to edit it, and you should be able to publish it, right? If you're a lead, that also applies to you. That also applies to Mommy if she's on the platform, and everyone else who should have access to a post and who should be able to say that this post is good enough to go live, right? But oracles can only enter the post and submit it. If they enter the post and submit it, it is going to show the post that they have submitted is going to show like this on their profile, right? So these are posts that are still attached to me because I loaded them. I need to find the right people and assign them to it. But this is what is attached to my profile, right? So if I open my profile, only post assigned to me. Again, I can't see someone else posts because those are that person's posts, right? And there are different levels of permission in here that allows me to be able to do that. And all these are instructions that I've already written down, that have already been provided to the system in order to be able to do that. And we're going to be giving such instructions at a very low level up till about 5:45, 5:50, where we can have some fun and then we can ask some questions and I can drop some resources and then we can close for today. If it is, are you done? And in order for you to write a program, okay, all right. So we're still talking. We still have a little bit more time. In order for you to write a program, you need to write it in a language that your computer can understand. Because like I said, it's a set of instructions. I can speak about 5 Ghanaian languages fluently, but in total, I can speak about 7 of them, right? Now imagine this. Imagine you can't speak a certain language. I work in the Volta region a lot, and I can speak the Ewe language, and I came and I gave you some instruction in Ewe, and you can't speak it. How would you know what I'm saying in order for you to be able to carry out the instructions? That would be very bad, and that would also be very annoying, right? Even if you understood the language and I said it in a wrong way and the grammar was wrong, you still wouldn't be able to understand and carry out the instructions, right? So if I came and I was like, Richmond, take, do, me, go, jump, high, run, sit. It doesn't mean anything, right? And you're definitely going to wonder if I am okay or not, if everything is fine with me, right? The same way, in order for you to give your computer instructions that it can follow, you have to give it in a language that it understands. And this language is what we refer to as a programming language, right? Now, There are several programming languages out there, but unfortunately, your computer can only speak one. And so, in order for your computer to be able to speak, to understand the instructions that you're given, your computer needs what we call an interpreter or a compiler, right? For whatever instructions you've given, right? So if I write an instruction in C++, my computer doesn't inherently understand C++. C++, by the way, is a programming language. My computer doesn't inherently understand C++. And so it needs a compiler in order for it to be able to interpret that into machine code, right? That the computer understands in order for the computer to follow and execute the instructions. If I give instructions in JavaScript, my computer doesn't understand JavaScript. So I need a JavaScript interpreter to interpret that instruction into machine code, a language that my machine understands, in order for my machine to do that, right? So I could give Richmond instructions in Dagat. Maybe he doesn't understand Dagat, but I could give the instructions in Dagat, right? But I could have an interpreter translate that into English, which he definitely understands. And then he can follow the instructions and execute it. And these are called interpreters. So there are multiple programming languages out there, probably in the hundreds. A few, maybe 20 very popular ones, maybe 30 very popular ones, but definitely in the hundreds, right? And all these programming languages require an interpreter for your machine to be able to understand the code and execute it. Now, you can write your code in machine code, but please don't even attempt it, because machine code is tedious. It's just a bunch of zeros and ones that you need to write. You need to write them in the right order. You need to write them in the right way in order for you to get a desired effect. And so we have these nice programming languages that both we and our machines can understand. We can learn and our machines can understand, so they can carry out instructions that we give them, which is very important. Again, in order for your machine to understand what you're saying, you need the right syntax, you need the right grammar for your machine to be able to understand. Else, the interpreter is going to throw an error and say, bro, I know you're trying to speak Python, but what you're saying doesn't make sense to me. Please make it make sense so I can tell the machine to do what you want it to do, right? And the funny thing is that sometimes it's a comma that is missing somewhere, or it's a bracket that is missing somewhere. If you have a very good code editor, the code editor will do the check and point out the error even before the interpreter tells you, Charlie, this thing you are saying is not defined, or Charlie, the thing you've written, me, I don't get it all. So I cannot tell the machine to execute this particular instruction because it doesn't make sense. That is the whole reason why we use code editors and not normal text editors to write our code for Python and for the other stuff. Ebenezer, still slow? Okay, all right. But I'm sure you can follow through what we are doing, because you already have Anaconda, you already have a Python. So I'm assuming you've started learning, or you just started and you want us to wait for you.
Ezekiel,
Mommy,
we have about 20 minutes, We've been on for almost 2 hours now. So I don't know when you would want to run up, because some of us have to go and cook.
okay, mommy. So
Unless
he
otherwise,
says
I can leave you guys and then you continue. Yeah, but
he
I
says he
may
can
have.
follow. He says he can
Ah,
follow through. So let's
okay.
open our first folder and write some Python code, right? So write on your desktop. I hope everybody knows how to create a folder because I'm definitely not.
Creating a folder, normal folder.
Yes. So you
Oh,
can
we
go
know.
to your desktop, create a
Yeah.
new folder, and call it PyTuts for Python tutorials. PYTUTS. You can call it anything you want, but PyTuts is just as good. So now that you have that created, can you open up your Visual Studio Code? If you can't find it, go to the search in your taskbar and type VS Code. Yep. Just type VS or type the whole Visual Studio Code and select the one with the icon as we've been seeing in the presentation. If you hit that, it should open your Visual Studio Code and it should show you absolutely nothing like this, unless you already have something open in it. And I'll need a lot of responses from you because now we are walking through a procedure, right? Do we all have this open? Is the folder created? Is the Visual Studio Code open?
You said we should name the folder what?
PyTuts, PYTUTS.
PyTools.
PyTuts, PYTUTS.
Yes. Okay. And then we should do what again?
And then press enter to save the folder.
Yeah.
And then you can come to the search bar at the bottom here and type visual. Oh, sorry. Visual. Once you start typing, the Visual Studio Code app should appear at the top.
Oh, okay.
And then click that to open it. If you open it, you're going to see something like this, or you're going to see with a tab that has some writings in it.
Hey, it didn't appear. Visual. What did you type?
Visual Studio Code.
Hey, who downloaded it for me? Which one? Where did you put it?
I mean, it's an
Wow.
Apple. When you type it, you see that it's already installed.
It's not coming.
Okay, if it's not coming, let's do it in a command terminal. Everybody has a command terminal, right? Let's start from the command terminal. So first, let's verify that we have Python installed, right? So go to the search again and type CMD like this. And then select the one that says command prompt.
CMD.
Yes.
Oh, I'm not in the right space. Is everybody getting it?
Yes, please, I'm getting it. Are we running
Mommy, can you see my
administrator mode?
You said?
She doesn't have to run in admin mode. Can you see my screen?
Yeah, I can see your screen. And I thought you were in. Where are you in? Are you not?
I'm just on my desktop and I'm in the task bar at the bottom here.
The tax, yeah, desktop tax. Oh, okay, here. Sorry,
Yes.
I can't see where you said I should.
Okay, so let's verify whether we have Python and we can go on from there, right? So type CMD over here.
CMD.
You should see this black icon up here with command prompt.
Yeah, it's there now. Yeah.
Okay, click on that and then it will open a small window like this.
Mm-hmm.
Okay.
Okay.
Do we all have it?
Yeah,
Which one? Edufor. Okay, awesome.
I'm here.
So the first thing you want to do is either to type Py, which is the short form of Python, or type Python in full over here and press enter.
Where the cursor is 23320. So you should type Python or Py.
Yes. Or Py, yeah.
And then
press
enter.
Yes. If you press enter, you should see Python and then the version, right? And
Mine
then a
is
bunch
not
of
recognized as an internal or external command. Hey.
Python is not recognized as an internal or external command.
Yeah.
Oh wow.
On my laptop.
I
Richmond, are
have
you
the
sure you installed Python for mommy?
I installed the Visual Studio Code
Uh-huh.
and uh, the other IDE you told us to install.
Yeah.
So it means I don't have Python
I don't
installed.
mommy doesn't have Python.
From what Richmond
I
is saying.
I installed everything. Oh, it's error there.
No.
Oh,
Edufwa, are you okay? Because you're not saying anything. Okay, she's okay.
hey,
Okay, mommy, let's
Oh, you go
let's do
on with them.
something.
You go on with them. I'll get him. I'll follow. Go on with them. Those
Okay,
who
all
have.
right. So over here you can start writing your first program, right? Now the fun thing is that Python is a mathematical language. It's a very logical language, so it already understands mathematics to a very intermediate level. So you can start doing math operations here, right? If I do 2 * 2, which is 2 divided by 2, and I hit enter, I should immediately receive the answer, which is 1, right? If I do 4 star, if I do 4 star 5, which is how you write 4 times 5, and I hit enter, I should receive 20 immediately, right? So you can test it, make sure that the program is responding the way it's supposed to respond. If you write 4 times 5 and it says Richmond, you are in trouble. It means that you don't have Python installed. Maybe you installed Cobra or something. I don't know. Are you testing that?
yeah, it's
Ebenezer have
working.
gotten it. If what?
Okay,
Hey,
do
she
for two
just
has
sent me a
Ebenezer
thumbs
is
up.
going to say, oh.
Okay, mommy, we'll have a session where we will install the Python. I'm sure the problem is maybe it wasn't added to path during the installation. And if
Um.
it's not added to path, it's not going to be recognized as a language on your
Okay.
PC,
Oh, okay.
right? Okay.
Yeah.
So for those of us that have tested the Python and we know it's installed, now let's go and do something more interactive and something more exciting. I really don't even want to worry my head over command line stuff, right? Let's go straight to Visual Studio Code again. Open that, right? And then what you want to do is to go to File, and then you want to go to Open Folder, right? When you click Open Folder, it should open your File Explorer. And then you want to select Desktop, and then you want to select PyTools, and then you want to hit Select Folder. I'm going to go over again. So, File, Open Folder, not Open File, Open Folder, Open Folder, right?
Yeah.
Which is the folder you just created, because that is where we are going to be writing all our Python code, right? So you want
Okay.
to hit PyTools, and then you want to click Select Folder, right? Now, once I click that, you realize that it will ask you a bunch of things. Just check this box and say, I trust, or yes, I trust authors, unless you don't trust yourself. And then you realize that right here in this corner, in all caps, you're going to have the name of the folder appear here.
Yeah.
All right. So you have the name of the folder appear here. Another thing you need to do is to make sure that if you install the right extensions for the work you're going to do. The one extension that you need is the Python extension itself in Visual Studio Code. So I'm going to go over again where you're supposed to go. So originally, when you start, you should be here, right? Within Explorer. In the left corner, where you have the icons. If you come all the way down, this icon down here says extensions, right? You want
Yeah.
to click on that. You want to select that tab. And then inside the filter or search bar that appears up there, you want to type Python. It should be the first thing that pops up with this Microsoft badge beside it, right? Now,
Yeah.
if you haven't already installed it, there should be an install button at the bottom here, right? Hit that install button and wait. You probably have to wait for about a minute for it to install. If you
So
don't have this again,
I could have done this to get it installed, or
no, mommy, you still need a Python programming language on your PC.
oh,
So
okay.
we could add Python to your environment. Um,
It's okay, go on.
okay. So maybe when you have time during the week, we will install Python and add it to your environment.
Okay.